Have you ever stopped to consider what's happening far beneath your feet? We walk on solid ground every day, rarely thinking about the immense forces and hidden structures that lie kilometers below. It's deeper than subways, those bustling arteries of modern life that carve through the earth, deeper than pipes, the veins and arteries of our cities, or even the unyielding bedrock that forms the foundation of our world. We're talking about a realm that's usually out of sight, out of mind. But recently, scientists with their advanced tools and insatiable curiosity discovered something astonishing lurking in this deep, dark place. They found a gigantic, warm, gooey blob of rock, a massive anomaly hidden in the Earth's mantle. This isn't some static feature, it's slowly creeping beneath the northeastern United States, a geological leviathan on the move. And according to current projections, it's heading toward New York City. Don't worry, this isn't a disaster movie. There's no need to imagine skyscrapers crumbling or the ground opening up beneath your feet. The blob moves at a snail's pace, a geological timescale that dwarfs human perception. But its discovery is a game-changer for science, offering unprecedented insights into the inner workings of our planet. Imagine a colossal lava lamp under the ground, stretching for hundreds of kilometers. But instead of wax, it's a mass of superheated rock, a dense, viscous material far hotter than anything you'd encounter on the surface. This hot rock is slowly rising through the Earth's upper mantle, driven by the immense heat and pressure deep within our planet. This northern Appalachian anomaly is a geological puzzle, a deviation from the norm that has scientists scratching their heads. It's revealing that even stable regions like New England, seemingly solid and unchanging, hide dramatic secrets beneath their surface. The blob challenges old ideas about how continents form and evolve, forcing us to rethink our understanding of plate tectonics and mantle dynamics. It's a connection to the deep past, linking the ancient forces that shaped our planet to the geological processes happening right now. It's not molten lava, the kind that erupts from volcanoes and fiery displays. It's something different, more like thick, hot syrup, incredibly viscous and slow-moving. This immense mass is slowly pushing upward, exerting pressure on the layers above. Scientists use cutting-edge technology, from seismic sensors to advanced computer models, to uncover these hidden worlds and map the blob's extent. This discovery is a powerful reminder that our planet is alive and constantly changing, even in the seemingly solid ground beneath our feet. This journey into the Earth's interior, to understand the nature and behavior of this anomaly, is one of science's most exciting frontiers. So, let's dive in and explore what this mysterious blob is, unraveling its secrets layer by layer. We'll investigate where it came from, tracing its origins back through geological time, and we'll consider what its slow-motion journey means for the Northeast and for our understanding of the dynamic planet we call home. So where exactly is this mysterious blob hiding? What part of the Earth is playing host to this geological enigma? The Northern Appalachian Anomaly, or NAA as it's known to scientists, sits deep, far beneath the surface of central Vermont. It's a hidden world down there, and it extends into western New Hampshire, quietly influencing the landscape above, and further south, reaching into western Massachusetts, a silent giant beneath our feet. You won't see any signs of it on the surface, no telltale clues visible to the naked eye, no steaming vents releasing geothermal energy, or bubbling springs hinting at the heat below. The landscape remains serene and undisturbed. Its top is buried approximately 125 miles underground, a staggering distance. That's deeper than we've ever drilled. The NAA is truly enormous, a geological titan lurking in the Earth's depths. It stretches about 250 miles wide, an immense horizontal span. Imagine it stretching from Boston, a major metropolitan hub, all the way to New York City, if placed on the surface. That gives you a sense of its sheer scale. It's not just wide horizontally, it's also incredibly thick, extending deep down into the Earth's mantle, the layer beneath the crust. This is no small, insignificant pocket of warm rock. It's a continent-sized feature, a geological behemoth hidden from view. This discovery was surprising to scientists, especially considering they thought the region was geologically quiet and stable. The blob is significantly hotter than the surrounding mantle material, radiating heat from within. This increased temperature makes it less dense than its surroundings and therefore more buoyant. Think of it like a hot air balloon rising through the cooler air above. This temperature difference is what drives the blob's slow but persistent upward movement within the mantle. Its presence in a region without recent volcanic activity is a real head-scratcher and a source of intense curiosity for geologists. The NAA's immense size means it could potentially influence everything, from the subtle changes in mountain heights to the patterns of earthquake activity across New England. Scientists are just beginning to scratch the surface, working diligently to understand how this hidden engine, deep beneath our feet, shapes the world we see and experience above. How did scientists find a giant blob buried so deep underground? The answer: seismic tomography. It's like a CT scan for the planet, using seismic waves from earthquakes to see inside the Earth. Thousands of seismometers worldwide record these waves, which travel at different speeds depending on the material they pass through. Hotter, less dense rock, like our blob, slows the waves down, while colder, denser rock speeds them up. By analyzing tiny delays in wave arrival times from thousands of earthquakes, scientists can map out hot and cold regions deep below. Powerful computers turn this data into a 3D map of the Earth's interior. That's how geologists first spotted the NAA, a huge area beneath New England where seismic waves moved unusually slowly. This technique revealed a massive, hot anomaly no one expected. Seismic tomography is revolutionizing our understanding of what lies beneath our feet. Thanks to this technology, we can now explore the invisible world deep inside our planet. The Northern Appalachian Anomaly is a true geological oddball. Most dramatic Earth activity, volcanoes, earthquakes, happens at tectonic plate edges, but New England sits in the middle of a stable plate. Finding a hot, active upwelling here is like discovering a jungle in Antarctica. Mantle plumes usually create volcanoes like in Hawaii or Yellowstone, but the NAA hasn't produced any surface eruptions in over 100 million years. The blob is hot enough to be detected, but not enough to break through the thick North American plate. Its gentle, hidden nature challenges what we thought we knew about mantle plumes. The NAA suggests there are subtle, less dramatic processes shaping the Earth's interior. It's a reminder that even quiet regions can have dramatic stories unfolding deep below. If the NAA isn't a typical mantle plume, where did it come from? The answer goes back 200 million years to the breakup of the supercontinent Pangaea. As Pangaea split, hot mantle material welled up, and a piece of this superheated rock may have become trapped under the forming North American plate. This anomaly has been lurking ever since, a remnant of ancient chaos. Over millions of years, the less dense blob has slowly started to rise through the denser mantle above it. This process, called Rayleigh-Taylor instability, is like a slow-motion bubble rising in thick stew. The blob's journey is gradual, unfolding over tens of millions of years. We're lucky to live at a time when technology lets us finally see it in action. One headline-grabbing fact: the NAA is moving very slowly toward New York City. It creeps southwest at about 0.4 inches, 1 centimeter per year, roughly the speed your fingernails grow. The North American plate drags the blob along as it moves, like molasses on a conveyor belt. So, when will it reach New York? In about 50 million years. For perspective, modern humans have only existed for 300,000 years. New Yorkers have nothing to worry about, but the idea of a massive geological feature moving beneath a major city is awe-inspiring. The blob's journey is a story written in deep time, unfolding over eons. It's a powerful reminder that the ground beneath us is always changing. The NAA's slow creep is a testament to the persistent forces shaping our world. The NAA might not be a lone blob. It could be part of a much larger wave-like pattern in the Earth's mantle. Some scientists think it's the crest of a giant mantle wave, with alternating hot and cold zones beneath the eastern U.S. seismic maps show hints of this pattern. Hot, slow regions like the NAA, and cold, fast regions nearby. The edge of the North American craton may help create these waves, setting up slow-motion convection currents deep underground. This mantle wave idea is changing how we think about the planet's interior. It suggests that powerful forces shape continents from within, not just at their edges. The NAA is a key clue to these hidden patterns. It's a window into the slow, rhythmic pulse of the Earth's deep interior. The NAA isn't just a deep curiosity. It affects the surface too. Small, frequent earthquakes in New England often line up with the blob's edges. The hot, buoyant blob pushes upward, stressing the crust and making faults more likely to slip. Its heat weakens rock, making tremors more common. The blob also influences the landscape, lifting parts of the northern Appalachians and even the Adirondacks. This topographic rejuvenation is a slow-motion battle between erosion, and the blob's upward push. The NAA is an active force, subtly shaping mountains and triggering tremors from deep below. It's a hidden engine, sculpting the American landscape. The discovery of the North American Anomaly, or NAA, as it's come to be known, is fundamentally rewriting what we thought we knew about the geology of North America. It's forcing us to reconsider long-held assumptions and delve deeper into the complexities beneath our feet. For years, geology textbooks painted a picture of continental interiors as ancient, cold, and frankly boring places, regions where geological activity was minimal. But now, thanks to the NAA, we're realizing that these areas can be surprisingly dynamic and active, harboring hidden processes we never suspected. The NAA serves as undeniable proof that powerful thermal processes, driven by the Earth's internal heat, can occur far from the well-understood dynamics of plate boundaries. It challenges the notion that geological activity is solely concentrated at these edges. This groundbreaking discovery opens up a whole new set of questions. Are there other hidden thermal blobs lurking beneath seemingly stable regions worldwide, waiting to be discovered? Could this be a more common phenomenon than we ever imagined? The Earth's mantle, the layer beneath the crust, may be far more complex and lumpy than we previously thought, filled with a dynamic interplay of upwellings, where hot material rises, and downwellings, where cooler material sinks, with these processes unfolding over vast stretches of geological time, lasting hundreds of millions of years. The advanced technique of seismic tomography, which uses seismic waves to create images of the Earth's interior, made this discovery possible, powerfully demonstrating the ability of modern science to reveal the invisible structures and processes hidden deep within our planet. The NAA serves as a humbling lesson, reminding us that our planet is still full of surprises, holding secrets that we are only beginning to uncover. It underscores the fact that our models, no matter how sophisticated, are ultimately just simplifications of a far more complex reality. The real Earth, in all its glory, is incredibly intricate, constantly dynamic, and profoundly mysterious. This discovery of a slow-rising blob is inspiring a new generation of geologists and scientists, encouraging them to look deeper, to question established paradigms, and to challenge what we think we already know about our planet. It's a beautiful and compelling example of the scientific method in action, demonstrating how a single discovery can spark a revolution in scientific thought